Hey guys, welcome to the Skills Integration Challenge for Chapter 2 for CCNA 4. This is Packet Tracer 2512. Now, this was kind of making me scratch my head earlier because we were having to figure out a couple of things. We've got some blank spots here on this G00 subinterface 25 on R2. We have to figure that one out, and then we have to figure out the addressing for PC25. This is supposed to be in a certain, we're supposed to figure out this subnet range. And what I did is I came through here. Let's give this a 192.168.1, and it gives us this subnet mask here. So class 24. It says here 192, this is the address space that we're given. Additional space, address space is available between VLANs 15 and VLAN 1. Notice that VLAN 15 starts at 0 and then 1, even though it's VLANs can be anything, but the subnet is a little higher. VLAN 25 needs enough spaces for 50 hosts. Determine the subnet and complete the subnet table below. Alright, now if you're struggling like this with this like I did, I went to my trusty IP addressing table figure outer, and you guys can of course have this. Just email me at whalehitter@gmail.com and request this fancy dancy Excel spreadsheet. Just make sure you tell me what video you have saw it in. That way I know what one to send you, because I got a few different sheets floating around. Anyway, so let's pull this up here. For a /24, basically these three octets are locked in. Now this is the stuff you learned in CCNA 1, so duh, right? Now what we have here in VLAN 15 is not a .0 but a .128. So what that means is, come on, there we go. That means that they borrowed a bit. So it's a /25 now. So this one bit's turned on, and they're borrowing this because they need enough addressing space for 100 different hosts. Now it gives you a range of 1 to 126. So you get 126 hosts that you can address, but that'll satisfy the 100 host range. Now the next subnet that it wants us to create is subnet or VLAN 25, which requires 50 addresses. Now what we do, if you'll remember back to variable length subnet masking, what you do is you increment the bit that you have. So we're going to take that 128 and turn that on by doing this 128, enter. Now that bit just turned on, and then you move over another bit, or as many bits as you need to, and then you pad with zeros, right? So this is going to be a 26. Okay, so we're just moving over one. So now everything from here back is the network address. Everything from here over is going to be the host address. Now if you take all of these different bits and all the various combinations that you get, you're going to have 62 different addresses that are available from 129 all the way up to 190, but that'll satisfy the 50 addresses. Do you see what I'm saying now? So what we do is we take this blank right here that we have to fill in, and we turn it into this right here. So 192.168.1.128, that's our address, our network address right here. And then here's our subnet mask, 255, 255, 255, 192. So see how handy that is? Now up here, well, let's see here. It says R2 G00 subinterface 25. It's the first IPv4 address, which would be a 129, right? So that's what it is. 129 is still the same address, network subnet mask, excuse me. These all get the same subnet masks. The PC25 gets the second IPv4 address, which would be the IPv4 address of 192.168.1.130. And then L25 gets the last IPv4 address, which would be that 190 right there. Okay, so we just go through and fill those in with the appropriate addressing for our subnet masks and our default gateways. So that's how we figure that out. Now, once we go through and start addressing these stuff, it'll start giving us points. So let's do that. Let's start with our printer. Go to configuration. Now, the gateway address has already been filled in here, and it comes pre-filled in from the factory, pre-filled in from Cisco. So we just click on that and hit enter, and you're going to get 2 points straight away. Now we're going to go over to our fast Ethernet interface, and we're going to address it according to our addressing table right here. 192.168.1.190. Our subnet mask is 192. So we should get a few points for that. Bring that down. Let's do our PC 25 now. Get him addressed. Oops. Come on. Oh, I'm pressing the wrong button. 192.168.1.130 if I'm not mistaken, right? 130, yep. Okay, let's give this a little copy-paste job. Down here, 192. And this will be 129. Okay, we can fold that down. So those are all addressed. Now we just go to that R2 rather, subinterface 25, and address that too. Password Cisco, password class. Now I just want to show you guys something. It tells us that we need to address the R25. It tells us both to configure IPv4 addressing on necessary end devices. Well, this is not an end device, it's an intermediary device, so that kind of confused me, but still you'll notice that none of the sub interfaces have any IPv4 addressing done. They have their IPv6 addressing, but not their IPv4. So not only do we have to do our sub interface 25, we have to address all the rest of them as well. Just bringing that to your attention. G00 subinterface 25 gets created now. Encapsulation D.1 25. You know what? I forgot one command here. We want to do our, since we're going to be addressing IPv6 addresses, let's just get in the habit of doing our unicast routing command. I typically forget it, but let's not do it this time. Right? Let's not forget it. IPv6 address is 2001. Now what do we got next? You know what we can do? That's right, guys. Copy, paste. Just add that in. Now our link local address link local. So those two are done now. Let's go to our subinterface number 1. Alright, here we go. So let's see here. Our subnet mask, oopsie daisy. Our subnet mask is going to be 224. IP address is 193. So that one's ready. Let's Let's go to 99. Let's go to 15 actually. So that's 15. Then the IP address is going to be 128. And change this to a 1. Now remember, there's a note right here that says, on R2, configure inter-VLAN routing. VLAN 99 is the native VLAN. So let's just do that now instead of having to come back and do that later. Again, that's a 224, and this gets changed to a 1 or a 225 actually. Okay, that's 223. Oops, G00. No shutdown because we need to turn that interface on. Okay, now it's on. Looks like we're done here on that. Let's hop over to our switch now. Same thing, Cisco as the password, class as the privilege exec mode password. Configuration terminal. Now it wants us to create this new VLAN called VLAN 86 name black hole. Let's do that. Okay, once done with that, interface F01 is going to be our native trunk. Okay, now we'll do our, let's see here, interface range F07 through 18, switchport mode access. Which one are we on here? Oh yeah, there it is, 15. Okay, now we're going to be doing 19 through 24. Change it over to 25. Okay, now this range down here, it says F02 through 6, comma, G01 through 2. And we want to secure those by putting them on the black hole VLAN. And just for making sure everything's nice and secure, we're shutting them down so they're not used at all. Okay, we're done here. Let's move on. Next, it says that we want to configure triple P on R1 and R2. We want to use triple P with CHAP for the shared link. The password for CHAP is Cisco. So let's open up R1. Same thing. Cisco in class. Okay. So the first thing we want to do is create a username. The username that we're going to use for CHAP is not the username that you would typically use for logging into this switch. You're going to be using the username to log into the other switch. So the way CHAP works is the username you supply has to match the host name of the switch. So when R1 asks for the authentication from R2 through CHAP, R2 has to supply the username that matches R1's host name, and vice versa. When R2 asks R1, hey, what's the password or what's the username, he has to supply a username that matches his host name right there. So we're on R1, and we need to supply it with an R2 host name, username, / thing, authentication stuff. And our password is going to be Cisco. All right, now let's go to interface S000, and we're going to use our encapsulation protocol. It's going to be point-to-point protocol. So it's going to bring it down because it hasn't been configured on R2, So he's using HDLC, which is a different language a different language or encapsulation language than point-to-point. So it's going to go down because you can't communicate. Next, let's do our authentication, and that we're using CHAP. Okay, so that one's done. Let's go over to R2 and do the same thing. R1, password Cisco. Okay, now it's going back up because we've configured the authentications correctly and given the proper username, so now they should be able to communicate once again. Alright, so on R1, configure an IPv4 and IPv6 default routes using the appropriate exit interface. Now we're going toward the internet, the ISP, so we're going to use S001 as our exit interface. There we go. A lot of this should be old hand to you guys. You've done this enough, right? Alright, what's next? R2. R2 needs to be configured with an IPv6 default route. So let's go over to R2. And his exit interface has to point to R1, so it's going to be that S000. Okay, that's done. Routing, configure IPv4, oh yeah, we already did that. Configure IPv4 OSPF using the following requirements. Use the process ID of 1. So we're on R2, let's just keep using that one. So router OSPF 1. All the interfaces that we're going to be doing are going to be in area 0. R2 is going to be using this router ID of all 2s. Advertise specific subnets on R1 proper blah, blah, blah. Okay, so we're on R2. Now we have to propagate specific subnets. How we're going to do that is right here. We have to advertise every single one of these subnets and sub-interfaces. So let's bring up our trusty thing here, and we're just going to start filling these in. So here we've got 193. Now this right here doesn't really matter as much. I mean, it could be anything. We know that the first 3 octets are going to be used at the very least, but we'll leave them filled in. So 193 here. And then the wildcard mask is what we're after. So a 224, I think that's a /27 if I'm not mistaken. Yep, 224. So our wildcard mask is going to be 31, and that's what we use on a OSPF. So network 192.168.1.193, and then we use our wildcard mask of 31, area 0. Okay, that one should be right. Let's see if we get some points. If we did that right, we got a point, so we did it right. Okay, let's do our up arrow. Let's do the next one. This is to be a 1, so let's change that. 1, and then it says 128. So that's a /25. So our wildcard mask is going to be 127. Let's see here. Oh, you know what I did? I didn't do the, let's do 31. Change this to a 192 because that's the network address. See if it makes a difference. Yeah, it figured it out. Okay, let's do this. 127. Oops. 127. This is going to be a 0, since that'll be the network address, if I'm not mistaken. Network address, yes, 0. So enter on that. Get ourselves another point. Okay, next, let's do a 129. 129, that's going to give us a 128 network address. And we've got a 192, that's a /26, which is going to give us a wildcard mask of 63. Let's see here, 124, so we can just do that up arrow till we get to that 24 up here. That was a 24 as well. So it's a /30, .31 for the wildcard. And then we've got a 225. I think that's another 224. Let's just check that out quick. And that's a 27. So yeah, 24. 24. Okay. So enter there. So give us our last point. Oh, then we have to do this 10 network. .0. Since it's the /30s go in increments of 4, so that's a 1 that'll drop down to a 3. Alright, that'll drop down to a 1, and the increment of 4 will be a 3. Area 0. Should get our last, yep, 85. Okay, we're humming right along. Boy, that was tedious. Okay, what else did it want us to do? That should be it here. Let's go over to R1. We're going to do the same thing. Router, OSPF 1. These ones has a much fewer subnets to do, so it should be a lot easier. We're going to do our router ID, quad 1, network now. Whoa, where am I going? So that's going to be that same address as we had before on our last one. So 10.10, 1.1.0, and then the wildcard mask of 3. Area 0. Okay, and then we have let's copy this one. Copy. Just paste that in there. That's going to be a 5, since it's usually just the next one down. But we can check that for make sure. 209, 165, 200, 226. And that's a /30. So network address, I was wrong, drops down to 224. And then the wildcard mask is 3. Area 0. Okay. On R1, propagate the IPv4 default route created. So we'll just give that default information originate. Configure IPv6 OSPF using the following requirements. Use the process ID of 1. Okay, so let's just exit out of here. IPv6 router OSPF 1. Router ID is all 1s. Now we can exit out of here and go to our interfaces and configure it there. IPv6 OSPF 1 area 0. Okay, that's done. We got both of our interfaces done there. Let's go to R2. Exit IPv6 router OSPF 1. Okay, interface 000, IPv6 OSPF 1 area 0. KG00.1. And there we go, boys and girls. We got 100 points. 100 points. We are so good at our jobs. Now, if this video has helped you in any which way, please hit that like button. Also, subscribe. We're coming out with videos like this. You can look forward to Chapter 3 here in a little bit. Talk to you guys later. Peace.